Good evening. Thank you all of y'all for coming tonight. Appreciate a great turnout. I guess everyone's excited about Docker as much as we are. So I am, just a quick introduction, so I'm Chris Hample with Booz Allen Hamilton, and we part of the Austin office, and we're here on the 5th floor, and we'd encourage y'all just come visit us whenever, come down and chat with us. We'd love to talk. Just a quick thing, so Booz Allen Hamilton's traditionally known as like traditional IT consulting, primarily for the government. So that's changing. So part of what we're doing is a lot of new products, open source. We're doing a lot of cool things and a lot of cool partnerships. So part of those partnerships are with incubators. So we partner with 1776 in DC, Cambridge Innovation Centers in Boston, and Capital Factory here in Austin. Part of the things we want to do with Austin is to really focus on how can we contribute? How can we give back, and how can we be part of the Austin community and strengthen the Austin tech community? And one way of doing that is having talks like tonight and bring in companies like Docker and have them, as a way to introduce them to Austin and be part of Austin. So one little quick logistics for tonight. After we'll have a talk, some Q&A session, and then please stay. We're going to have drinks and food still till about 9:30 or 8:30 or something along those lines. We'll just stay whenever.
Just stay in here.
She'll throw you out. Yeah. No further ado, this is Patrick Chanazon here from Docker to talk to us tonight.
Thanks. Thanks very much. Hi, everybody. My name is Patrick Chanazon. I'm at Docker. The talk today will be about the Docker platform and all its ecosystem. To get the joke, our logo is a whale. It's been very popular. There are tons of T-shirts about that and all that. And when I moved from, before joining Docker, I used to be at Microsoft, where my role was to bring all the Docker ecosystem on Azure. And I used to give these talks about the whole Docker ecosystem and all the orchestration players and all that. And one of my friends told me, hey, you're like the Commandant Cousteau, because I'm French, as you can hear from my accent. So this talk is like a tour of the subaquatic life with all these strange creatures that swarm the oceans in the Docker ecosystem. So a little bit about myself. I've worked at many different companies. Essentially, so I'm French. I came in the US 10 years ago. I've been at many different companies. My career is like two parts. For 10 years, I built platforms at Accenture, Netscape, AOL, and Sun. And then I moved to Google in 2005, where I was lucky to be the first one to be hired to do evangelism when they started doing platforms, first with ads and then e-commerce, then social, then HTML5, and my last stint was to create the developer relations team for cloud when we were starting with Google App Engine. After that, I moved to VMware to take care of Cloud Foundry and Spring, and then I moved to Microsoft to do Azure. And 4 months ago, I just moved to Docker, and I explain why. But before we get started, I'd like to know a little bit more about yourself. So, who here first is an active developer, is coding or opening a text editor and IDE every day or compiling code? Okay, so we have a majority of developers. Good, because I go into like in-depth demos to show you what you can do with Docker and some of the tools. Another question is, who here is building enterprise software as opposed to like consumer or startup type of software? Okay, so we have a majority of enterprise software, consumer, okay, mobile app developers, all right. Now, in terms of languages, .NET developers here. Wow. It works in Docker, though. And then any Java developers? All right, Node.js, Python. Okay, so we have a pretty good mix here. Great. So before we get started, I'd like to talk about why I'm here, and I don't know about you, why you're here. My reason for being part of the IT industry and for building software is when I was a kid, I used to read lots of science fiction when I was around 10 to 15, especially Asimov and Arthur C. Clarke. And I was picturing my future when I would be old, which means like today, 47. I was picturing a future with smart robots, like in iRobot by Asimov, or predicting the future thanks to historical data, like in Foundation. Or really smart machines to whom we could talk to, and I'm not talking about Siri here. And I don't know about you, so I went in that industry and I was dreaming of a future with really smart machines and eventually flying cars and going to the moon and stuff like that. And I've been very disappointed. Very, very disappointed. I had a great career with some of the best companies in technology, most advanced stuff and all that, but still I'm disappointed. In Silicon Valley right now, there's kind of a trend, a fashion, I would call that. It's called the singularity. There are lots of people in there, like Larry and Sergey at Google are really fans of that. They hired Ray Kurzweil, who wrote the book about this. The theory of these guys is to say they're taking Moore's law, like the progress that happened in hardware, and they're back extrapolating that in the past to explain that in the future, like the progress we're making is so fast right now that in 20 years, machines won't need us anymore. Now, most of you are building software. Personally, I think this is bullshit. And the reason for it is in this next slide, where what you see on the left is Moore's law. So Moore's law transistors double every 18 months. It lasted for 40 years. It's still going pretty quickly, or it's running strong. So right now, the machines we have today are 1 billion times more powerful than 40 years ago. Now, what you see on the right, I'm pretty sure you recognize that. That's the productivity improvement over the same 40 years for software developers. And there, the factor, I think, is 9. It's not 1 billion, it's 9. And to me, that's the main issue. That's the thing that is blocking us from building these smart machines and advanced systems. It's developer productivity. And that goes to my reason why I decided to join Docker a few months ago. It happened to me that realization that there was a new technology that allowed you to build stuff differently. The first time it happened to me was in '95. I was working at Accenture at that time, and I was building COBOL mainframe applications for invoicing for the French national operator. I had some fun with aspects of this, but I was seeing, like, I tested the browser and I thought, hey, we could put a server on the back of that, we could start building applications in HTML, and all the client server applications and the kind of mainframe application that we were building, we could just move that to web apps. And then I joined Netscape, and I spent the next 15 years building that type of apps. When I started using the browser, I really had an epiphany. And when I started using Docker, I had the same kind of epiphany. This is a technology that will be more proactive and to build applications in a different way, based on small services as opposed to a big monolith. A little bit about the Docker as a company. So our mission statement is we build tools of mass innovation. What that means is that there are tons of creative people out there, new technologies all the time. The problem is a barrier, people don't know how to use it. Our goal is to make that easier. And in that context, where do mass innovation come from today? It's from programming. And so our goal is when there's a new technology that's coming in, our goal is to just make it programmable. Now, what's the best platform that people can program with today? It's the internet. And so the problem with the internet is that today, when developers want to program things that run on the internet, it's completely siloed. So I'm not even talking about, like, you have all the mobile platforms, Android, iOS, then on the cloud side, there's lots of different APIs out there. There are platforms as a service, infrastructure as a service. And then you have the language stack, so you really have to pick your stack, and usually you're stuck in that silo. The goal of Docker is to create a software layer to program that in an easier way. So that kind of gives you an idea of what we're after as a company. In terms of business opportunity, because like many of you are working for companies and we don't all program software for nothing, there's a business angle to all this. Once you, Marc Andreessen said a few years ago, software is eating the world. This opens up a lot of possibilities, but at the same time you need to program for that, and programmer productivity and speed is really key to unlocking all that value. As developers, we tend to relish into complexity. Some of you, maybe who are working on government or military systems, you've seen that in the commercial world. It's very true as well. We build hugely complex systems that are more and more difficult to understand. Recently, I love this quote. So that's a quote from Richard Watson. He's a Gartner analyst. He wrote a great blog post based on a report he wrote for Gartner. Before joining Docker, I helped establish the concept of platform as a service when I was at Google. Google App Engine was the first platform as a service. Then at VMware with Cloud Foundry, we tried to build a platform as a service that you could install behind the firewall that was open source and multi-infrastructure. The thing is, these platform as a service are quite limited, and they limit what the developer can use. Basically, if you accept the premise and the constraints of the platform, then it will scale your code for you, but then there are tons of things that you want to put in there that you cannot. And to me, one of the benefits of Docker is that it allows developers to put a lot of dependencies that were not possible in platform as services, so maximum flexibility, and then gives ops the control to make that work in production. Another aspect is speed. Docker is really good for accelerating the pace of development. And to optimize for what, I love this quote from Adrian Cockcroft from Netflix. He calls, at Netflix they call that the intimbiage, the mean time between idea and making stuff happen. That's really what companies who are innovating are after right now, and there's a lot of business benefit to be the first to create new markets thanks to technology. So agile methodologies, I remember reading the XP book in 1999-2000. It took 10 years, but starting in 2010, it started to be really widespread and used in the enterprise. And right now, it's moving with DevOps. Both Agile and DevOps are two trends that are really accelerating the developments. And when I'm talking about DevOps, the relationship between Dev and Ops have always been really bad. Like from the mainframe era, where they really couldn't stand each other. In client server, devs were building the client side that needed to be deployed on lots of Windows machines everywhere. And then they needed to talk to the sysadmin who managed the Oracle database and was in his ivory tower. For those of you who are old enough, you must remember these years. It wasn't much better. When the internet revolution and the web revolution happened at the end of the 90s, it was even worse. I remember being in meetings at Netscape where a meeting with like 15 people, half of them ops, half of them devs, none of them had talked to each other during the past 2 weeks. And they just realized there were tons of issues for the stuff we were supposed to ship the next day. So that was really an awful, and they didn't use the same languages for development. It was Perl versus C++. It was really bad. Then in the past 5 years, I would say, thanks to first infrastructure as a service, continuous integration, and continuous deployment tools, and a pressure from the business for dev and ops to work better together, there was that cultural movement called DevOps that was born. I think Docker is really a key enabler for that, because the container is the right level of abstraction for dev and ops to work on, or to collaborate around. Before we go in the technical stuff, I wanted to talk a little bit about how Docker positions itself in the cloud market, and that's my opinion. That's actually a slide I built for my ex-team at Microsoft to show them how I view the market. And I think I worked for at least 4 of these players. So to me, it's a 4-horse battles. There's a big battle for cloud between Amazon, Google, and Microsoft. Then there's the hybrid aspect, where VMware really owns private cloud. Microsoft is kind of in between. They have a really nice strategy, hybrid strategy with Azure Stack versus Azure. And then Amazon and Google are really only public cloud. Google with Kubernetes is starting to have a hybrid strategy. And I compared that to movies. To me, VMware is like 300. I don't know if for those who saw it, it's the story of the Spartans. They're very courageous and they shout Sparta and they go to battle, but we all know how the movie ends. Amazon, to me, they're like Pacific Rim, and that's my perspective when I was at Microsoft. So for those who haven't seen the movie, there are huge monsters who come out of the Pacific Ocean from a fault at the bottom of the ocean, and they just invade the world. And here, thinking the enterprise market. And our goal at Microsoft was to throw them back in, like in the movie. Google, it's very much like Back to the Future. I remember when I was at Google, I was trying to sell App Engine for business to companies when we introduced a version of our platform as a service, public cloud only for companies, and that was like around 2010 or 11. I'm going to see companies and they laughed at me and they said, "Oh, you can do only Java and Python, and you cannot install anything behind the firewall." And then they told me that's too futuristic. Maybe we'll do that in 10 years, but for now, just come back when you have something useful for us. And to me, Google, that feels really like that character in Back to the Future, Marty. He's an adolescent from the 80s. He goes back to the future, or he goes back in the past in the 50s, and he starts playing hard rock to these people who haven't discovered rock and roll yet. It doesn't work very, like the kind of silence that he gets is exactly the feeling I had in front of enterprise customers as a Google guy. I think Microsoft is Field of Dreams, build it and they will come. They have the right strategy and they're executing pretty well. And to me, Docker kind of changed that whole market in the past 3 years. And at Docker, we're partnering with all of these players because we play a role for enterprises, especially in the portability of workloads. When they want to choose a cloud, they're going to maybe use several public clouds. They're going to have a private cloud as well. And with Docker, you can move your workloads around. Docker is about containerization. Containerization is not something new. It existed since a long time with BSD shells, Solaris, Solaris zones. But what Docker made is that it made that easy to use. So it's a shipping container for code. Who here has used Docker already? Okay, so I just skip on the basic stuff. The company is doing well. It's 2 years old. We're still a startup. Why it's successful today? I think it's because cloud adoption is happening now after like 5 years of enterprises dragging their feet. It provides portability. It supports hybrid cloud scenarios, and it supports DevOps. Docker is also an ecosystem, and that's one of the interesting things I want you to retain from that talk. It's not only the Docker products, there's a whole ecosystem around it, and it reorganized the industry categories around it. So there used to be infrastructure as a service and then platform as a service on top of that. And now everything's been reorganized around like container orchestration. So at the bottom, you have the new hardware, which is your virtualization layer or your cloud layer. So VMware inside the firewall, Microsoft, Amazon, Google, and then smaller player like Giant. On top of that, you have an operating system. And all the players in there in the past year have introduced minimal distribution that are designed for the data center, where you have very few system components, and it's just designed to run very efficiently Docker containers. And all of these are shipped with Docker. So you have Photon from VMware, Project Atomic, CoreOS, who started that trend, Ubuntu Core. My favorite is Rancher OS, and the reason for it is Rancher goes all the way to get rid of everything from the operating system. You just have the kernel, and you have two daemons, system Docker and userland Docker. So all your user workloads are running in a userland Docker container, but then you have system Docker where your system services are running in privilege mode, so they have more access to the system. On top of that, you have Docker and all the tools that I'm going to talk about. On the left, you have add-ons, plugins, things like Flutter for volume management or Weave for network. And then on the right, it's a big zoo. This is like the real aquarium where you find lots of different species of orchestration engines. When you start to have lots of containers, you need to orchestrate them. And so it's a big race right now. I'd say the three big players are Docker Swarm by Docker, Apache Mesos by Mesosphere, and Google Kubernetes. Then there are lots of others. DAS, Cloud Foundry reinvented itself as a container orchestration engine. IBM Bluemix includes Docker, and they include Cloud Foundry as well. And there are other players like Apprenda and Tutu. Okay, so Docker itself, I talked about like containers, what they are. If you look inside of them, basically they're operating system level virtualization that are based on two features in Linux, which are namespaces and cgroups. So namespaces give you isolation for processes and file system and network, and cgroups give you control over memory and CPU and things like that. There's also one of the things that made Docker very successful compared to VM. When you're building a VM, typically it's like 2 to 4 gigabytes, and then you need to upload it to Azure or one of your favorite clouds, and it's hell. Docker has this really smart system of layered images where you inherit from a base image, and then every change you make to that image is a new layer. And these layers, when you download an image, they are cached. And so if you download an image that has like 15 layers and just your own additions, only your own additions are going to be uploaded there. And there's an inheritance system in the Docker file format where you can say, I inherit from this image. So that makes it super efficient to build images on top of base images that will be typically managed by IT. It's also a good definition of where the barrier is between developers and operations. So Docker evolved a lot in the past year, and at DockerCon, who among you looked at DockerCon videos or attended DockerCon? Okay, so not very many of you. So I will kind of do a quick recap of all the stuff we announced in there. But basically, Docker is, today, it's a platform to build, ship, and run applications, any applications anywhere. For developers, it looks like you start with a Docker file, so you can inherit from a base image. Then you have like operations in there. It's a declarative format, and you can add your source code in there, specify what the working directory is, run some commands, and then specify an entry point for where you're running your image. Once you've done that, you do a Docker build of your image, then you can push it to the Docker registry or Docker Hub, and then you just can run it into Docker Engine. So that's pretty easy. On top of Docker, once you have created several containers, one for your database, one for your logging service, one for your main application, you can assemble all of them into another declarative format in YAML that's called Compose. And you use another tool called Docker Compose. And when you do Docker Compose up with a file like this, what Docker Compose will do is that it will assemble each of the containers, deploy them, open the right ports, and link them together. So for a developer, to me, the Docker file and the Compose file have completely replaced the long README files that you had when you bring a new developer in your team. When you bring a new developer in your team now, you just need to give them Git on their machine and Docker. Then they can check out the code from the enterprise repository where you have your application. There will be a Docker file and Compose file in there. Normally, they should be able to do a Compose up and be up and running right away. After that, they need to dig into what's happening in there. But at least you just need to describe your architecture. You don't need to do yak shaving like you used to before, to set up different environments and all that. So there's been lots of new stuff announced at DockerCon. In Compose, there are more configuration options. There's a new experimental feature that's called Smart Recreate, where when you change, before Compose used to recreate all the containers. Now only if the configuration of your container has changed, it will recreate it. And that will probably become the new behavior. Docker Machine lets you provision in multiple virtualization technologies and multiple clouds, and actually most of them have drivers. It lets you provision virtual machine with Docker Engine pre-installed, as well as Docker Swarm, and it does all the configuration for you. So with Docker Machine, you can very quickly spin up a machine or a cluster of machine locally on VirtualBox, or VMware, or Hyper-V if you're on Windows. Or spin them up on Azure, or spin some others on Amazon or Google. So it's a really very easy way to get started. So it supports lots of, you can specify lots of operating systems for your machines, and it supports lots of, most of the big virtualization as well as cloud providers. What is new in 0.3 for those of you who are using machine? Actually, there's lots of very cool stuff in there. One of my favorites is that the generic driver. Very often, I remember when I was provisioning machines with Docker on Azure, I used to write these cloud init files. And I wouldn't rely on the basic Docker Azure image because I wanted, for example, to attach an external disk and have varlib Docker mounted on that, to add extra memory, to do some tweaks in the operating system. So now what you can do is that you can write a script or use any of the technologies like Chef, Puppet, Vagrant, or Terraform or Ansible to provision your VMs in your favorite cloud or infrastructure provider, and then you just use Docker Machine to provision the host with SSH access. So it's going to install Docker, create certificates, and do all that stuff for you. You can also specify Docker Engine and Swarm options, because Engine and Swarm have more and more options. And for example, when you're starting Swarm, you may want to specify labels or things like that that you can use for orchestration. For example, this machine has SSD, this machine doesn't. Now you can specify them when you provision these machines with Docker Swarm. Docker Hub, there's been lots of progress made on Docker Hub recently. There are more and more users and repos. It's been a tremendous successful project. At the same time, there's been lots of criticism lately that Docker Hub was slow and the user interface hadn't evolved. So at DockerCon, we released a new version of Docker Hub with a much nicer UI and a much faster tools. So it's based on the new distribution code. That's in the Docker code base. It's called distribution v2. And in Docker Hub v2, like the tools are much faster, they run in parallel, and performance is much better. So I don't know if some of you have noticed that, but if you update to a recent Docker, you will talk to the new hub, and it's really worth it just for that. So there's been a lot of speed up, and it's much more reliable as well. Docker Trusted Registry. So Docker is, we're a startup, but we're a company. We're not a non-for-profit. So we're definitely for-profit. We need to make money. Our business model is around subscriptions and products like Docker Trusted Registry, which you can install behind the firewall to host the images for the project that you're using in an enterprise. So that's definitely something to check out if you're building projects using Docker inside of a company. Yeah, so it has a bunch of enterprise features like there's a LDAP and Active Directory integration for role-based access control. audit and event logging, like the kind of stuff that you would expect in an enterprise product. And it's really easy to deploy. So easy to deploy, if you look at my Twitter stream, you'll see a picture of Roger, who's our VP of sales. So he's not an engineer. This afternoon, between 2 meetings in that office over there, he just deployed Docker Trusted Registry on Azure using the Azure Marketplace. It took him like 10 minutes. And he said, yes, I did it. So anybody can do it. It's pretty easy to use. Kate Malik, when I train Microsoft people who are used to Visual Studio and to have visual tools and not command line on using Docker, I was doing everything on the command line, and they told me, "Hey, there's no UI for this. That's crazy." I said, "Hey, no, sorry, it's Linux. It's like only command line and all that." And then came Kate Malik. It's a company that's been acquired by Docker a few months ago, and they have this excellent UI on top of Docker that lets you do a lot of the things that you could do with a command line, but in a very nice GUI. I'll show it to you. I'll show you a demo of that. And it's working on Mac and Windows, and they're working on Linux version as well. And then deploy it anywhere. One of the big news at Build and at DockerCon was that Microsoft announced that they were so all in with Docker. They liked the developer workflow, so they wanted the same workflow for their developers. So they decided to implement Docker, which is a technology based on Linux features, Linux kernel features for Windows. So what that means is that they modified Windows so that it has the same kind of isolation primitives that exist in Linux, and then they re-implemented, or they're working on it right now, Docker Engine on top of these new primitives for Windows workloads. Which means that when they ship that, so it will be a new version of Windows Server called Windows Nano Server. There's going to be a preview of that. The technical preview, I think, is planned for the end of this month, maybe beginning of August. So once you get that, you install Nano Server, which is their micro version of Windows Server. No UI, only PowerShell access. It's designed for the data center. That's what will run in Azure. Or that's what actually it's taken from the kind of version of Windows that are running in Azure today, to say the truth. So they're going to release that version with a version of Docker Engine based on that, which means that in most companies, or companies that have .NET have Java. Some companies are more towards one or more towards another. But basically with .NET, and very often you find both, especially in large companies. That means that once that ships with Docker, you'll be able, with the same Docker client, to talk to Docker engine that are Linux, Docker engine that are Windows. It's the same API, same management tools, and you'll be able to deploy your workloads, whether they are Windows or Linux, on these engines, whether they are Windows or Linux. So that also means you're going to be able to deploy Windows native ASP.NET applications on Windows and package them as containers. Now, if you want to get a feel for what it is today, if you're a Windows developers, actually there weren't anything in there, but basically they have a version of .NET, because .NET has been open source, so they have a version of container for ASP.NET v5. You can build ASP.NET v5 on your Mac and package them and run them in a Linux container. I'll show you that. That runs thanks to Mono. So it's all about DevOps. I told you about that. I just wanted to talk about that a little bit more. What that means is that the workflow for developers now is, inside, as a developer, I focus on my code, libraries, all the packages I need, my app and my data. And then I pass the container either to Docker Hub or Docker Trusted Registry, and then from there, the ops team is going to take these containers and set up an orchestration engine for them to run in an efficient way and secure way, and set up logging and remote access and network configuration, monitoring, and all that. So it's really the right abstraction level for developers and ops to work together. Now, one of the big things that was announced at the conference 3 weeks ago is networking. in the Docker that you have used until now, and actually until 1.7, the way networking works is that when you launch a container, we just and you can create some links between container with Docker links or with links in compose files. What the engine is doing is that it's going inside of your box, inside of the container, and just adding entries into etc host. So that's and then you need to open ports and all that. The machines cannot really see each other. In 1.7 experimental. So because of networking, we introduced that new feature called, or that new release vehicle called Docker Experimental. It's a different version of Docker that you can download from a different channel. You can install it in a VM or on your main machine. And what Docker, and they do daily builds of that, so you can update it every day. And Docker Experimental has two features that were announced at DockerCon. One of them is plugins, and the other one is the new networking feature. So now in Docker, networking is a first-class construct, so you can do a Docker network create. So you can create different overlay networks and attach your containers to them. And it works across multiple hosts. So it's really an overlay network. It implements what we call the container network model, where you have a network sandbox, an endpoint, and then that plugs into a network. So when you do a Docker create network, the way it's implemented is that Docker is going to talk to a network driver, and with the classic philosophy of Docker of batteries included but removable, we have a network driver by default that has been built by the socket plane team that has been acquired by Docker. And so they have this multi-host networking driver that lets you create these. And then when you create the container, it defers to the networking driver to just plug the container into the network. And that driver architecture actually goes to the next topic, which will be plugins. So there have been I think there are 5 plugins in development for Docker networking today. And some of them are ready already. So there's a RESTful API for network that you can look up over there. Drivers, we talked about that. The basic driver is the bridge driver. That was the old way of doing things. The new one is the overlay driver that really create different network namespaces. And you can create different networks that overlay your physical network and let you isolate containers into different subnets. So it looks something like that. So here you have your machines, you have your container, and you can connect them the way you want. And you can assign them, there's a notion of service, so you create a service. And then you can create, you can attach a container to a specific service or detach it. And so services resolve into machine names or not host names on the network. So if I create a network foo and I create a service bar in foo, I'm going to have a host name bar.foo, and if I attach a container to that service, I can ping that container at bar.foo. So that's really very convenient because lots of people have been messing around with service discovery, with things like console or etcd, or baking their own solution for that. I think that will simplify that kind of configuration a lot. So there are all these, so VMware, Cisco, Microsoft, Calico, and Weave and Nuage are building network plugins. The other big thing we announced is that Docker is really becoming a developer ecosystem in the way that we started exposing APIs. So networking, we talked about it, there's the driver model. Service discovery for Swarm, so Swarm can plug to etcd, console, or Zookeeper. We introduced a new volume driver where now for managing how you mount volumes, you can bypass the way Docker does that and call an external driver that will do that for you. So Flucker is providing that. And for scheduling as well, we did an integration with Mesos. So that's kind of a summary of all the integration points we have. So Swarm is now integrated with Mesos. There are all the volume plugins that have been introduced, the networking plugin, and service discovery for Swarm. Flutter, just to give you an idea of what a volume plugin can be used for. One of the things that happens is that when you're building a complex solution, like people are talking always about microservices, they are stateless. But at the end of the day, your services need to talk to something that's stateful, where you're going to store your state. And these databases or data services, if you're running them in container and you run that in the context of a big cluster with an orchestration engine that can like remove one machine and move your stuff from one machine to another, you need a way for stateful container to move. And right now, when you're mounting a volume, it's tied to the file system of the Docker engine on the machine on which you're running. So Flutter resolves that when you're using the Flutter driver, they have a nice system that's implemented using ZFS, the file system from Solaris that's imported to Linux. And what they do is that when you mount a Flutter volume, they create a ZFS file system for it. And then once you ask the container to move somewhere else, what they will do is that they take a snapshot of, so ZFS has very fast snapshotting capabilities. That's one of its strengths. So they take a snapshot of the file system, they move it to the other host where you want to move your volume. Then they, and that can take a few hours. If it's a large database, it can take a long time. Your application and your database continues to run during that time. Once they have moved most of the data, then they stop your container, so there will be a little bit of downtime. They take a diff of the changes that happen with the file system, and they move that diff with ZFS to the other host, and then they restart your database on the other side, mounting that volume. So to Docker, Flutter is doing all the work thanks to that plugin architecture. Docker just sees one container having to wait before it stops, and then stopping, and then the orchestration is going to relaunch it on another machine, and it's transparent to the orchestration engine that the volume has been moved. So that's what plugins are useful for. It's really for people to add some stuff to Docker that wouldn't exist without it. Docker Swarm. So we were talking about orchestration. That's one of the big area where there's a big fight. Docker Swarm has a very nice design. It's very uniform. Basically, when you're talking to Docker engines, each of your clients needs to target one engine, and that's it. And so you need to change your environment variable every time you want to talk to a different machine. With Swarm, basically, we replace all these clients by one server that's called Swarm. That's a Docker daemon. It talks the Docker API to the different Docker engines. And then as a client, you talk to it using the Docker API as well. So it's the same API both ways. As a client, you can specify some affinities and constraints. For example, you can say, oh, I want these two containers to be scheduled together. Or I want to schedule this Mongo workload on a machine that has the label SSD or things like that. And then Swarm will just distribute that according to several strategies. It has several of them. It has spread or bin pack or random inside of your cluster. So essentially, it exposes all your Docker engines as a single one. So it's a very simple design. The same API, to get started, it's integrated with machines. So the same way you can say Docker machine, VirtualBox, or Docker machine to Azure, a few parameters, and then the name of the machine, you just add like 2 parameters to say, oh, this is my Swarm master, and this guy is going to be my Swarm node, and this is their cluster ID, or something like that. There's also an aspect about discovery. By default, you can create a Swarm token that will leverage a service that's hosted by Docker. But if you don't want that, you can use console, Zookeeper, etcd, or even a static file. You can pass a list of IPs in a file to it. So the scheduler, I talked about it. It applies constraints. There are some knobs. And so it's really well integrated with machine. It's better integrated with Compose now. And what was new is the Mesosphere integration. Yeah, so let me tell you about the new stuff in Swarm. So who here has been using Swarm? Oh, very good. So we have a group of early adopters. That's great. So there are some new features in Swarm around replication. One of the problems in the design of Swarm is that you had this single point of failure with the Swarm daemon, the manager daemon. If it failed, like you were host, you couldn't control your cluster anymore. So now they added a leader election process between two different replicas. And so as a client, you don't care, you just talk to one of them. And you're always sure that you will have someone to talk to your cluster. The second aspect is one of the orchestration engine that's been around for a while, that's been created at Twitter, that's used by lots of companies and that is designed to scale to tens of thousands of machines, called Mesos. And lots of users of Mesos wanted to use Docker. And more of them were hesitating between Mesos and Docker. And instead of having a big fight, we just worked with Mesos, and now there's an integration between Swarm and Mesos. So the way Mesos work is that so you have masters and slaves. Actually, you can see them in there. So you have Mesos masters who decide where the workloads are going to go, and then Mesos slaves. On Mesos slaves, Docker engine is installed, and then what Mesos masters are doing is that they are talking to what are called framework in Mesos parlance, and they give them some offers. They tell a framework, for example. And there are frameworks, the most famous is called Marathon, but they are for Hadoop, Spark, and others. So the Mesos master is giving some offers to a framework, telling the framework, hey, I have a capacity on 10 machines with 2 cores. Do you want some of these offers? And then the framework says, oh, not now, I don't have any demand. Or yeah, I'm going to take half of it, or I take it all. That's how their design works. And so what they built is a Swarm framework. So Swarm becomes a framework for Mesos, and then when you're talking as a client to Swarm, you say, hey, I want to deploy Redis on a machine with 2 gigs. The Swarm framework is going to listen to Mesos master, and when Mesos master tells it, hey, I have 1 core with 2 gigs available as part of the offer, it's going to say, hey, I'm going to take this offer, and this is the container I want you to schedule in there. No, actually, it's not that. No, it's telling it, I'm taking this offer, and then it's talking directly to the Docker engine on that machine to provision it in the usual Swarm way, to provision your container there. But then that means that the resource management and the scheduling is done by Mesos. So that means that scheduling becomes pluggable in Swarm. One of the last thing I wanted to tell you about is a project that I'll demo for you. That's one of my favorite. It's not very well known. It's not a Docker official project, but it's done by Evan Hazlett, who's part of the team. It's called Interlock. One of the things that's missing from Swarm that exists in Kubernetes, for example, is Kubernetes has this notion of pods, replication controllers, and services are doing load balancing for you. So when you deploy a pod in Kubernetes and you tell it, I want 5 replicas of that pod. Replication controllers are going to create 5 replicas. And then when you assign it to a service that's assigned to a host name, the service is going to do the load balancing for you between all these instances. And this is all done through labels. That aspect was missing in Swarm. And now it exists thanks to that project that I like that design. It's very Unixy. Like we don't have that in the main product, but we have a utility that does one thing well. And what Interlock is doing is that it's plugging itself onto the Swarm event stream. So every time you talk to Swarm, or every time Swarm makes a decision, it generates an event. Interlock registers for these events, and then when it sees events with things like where you specify a host name, for example, when you schedule a container with a host name, with a minus host name option, or when you remove one like that, it's going to pass that event to a plugin. It has a plugin system. And there are two plugins right now, one for HA Proxy and one for Nginx. What the HA Proxy plugin is doing is that when it's seeing these events, it's saying, oh, okay, I'm going to regenerate. You just provision a new container for the host test.local. I'm just going to regenerate my HA Proxy config to do a load balancer for that host with that new backend. So that means that Swarm can move containers around, you can provision and delete them and scale them, whatever. The HA Proxy config is going to be always up to date. And that means that now with that you have load balancing and like in a pretty easy way in Swarm. And I'll show you how that works. And one other thing I wanted to do is there's a good opportunity to just add more plugins to Interlock for other load balancers like F5 or the Azure load balancer or the Amazon one. I'll go pretty quickly on the rest because I want to have a little time for some demos. So I'll go very quickly on the rest of it. One of the big announcements, we made two more big announcements at DockerCon. One of them is that Docker is built on tons of plugin, on tons of plumbing, and Docker essentially is plumbing. And we had criticism from the community for a while that, hey, it's this big integrated tool, and we'd like to use only pieces of it. And what we decided to do is to just go back to plumbing and take apart the pieces that Docker is built on and build separate projects out of it and rebuild Docker on top of these separate projects. And so the first one we've made, actually we announced two new ones. One of them is for security. It's a new tool called Notary. And essentially, if you want the 500 feet view of it, it's lots of people are doing curl to a URL, piping the result in SH, and anything could happen at that point. With Notary, if you inject Notary in there, you can have the code that has been on the other side that will be signed, and Notary will check that what you receive is exactly what you were expecting from the other side, and will forbid it to do its work. And so, applied to Docker, that approach will bring a lot of security features into images and provenance for images and things like that. The other aspect is it's a new tool called runC. So runC was called NSInit. It's a sub-project of libcontainer, which is the part of Docker that's creating containers, setting all these C groups and namespaces and networking. No, actually C groups and namespaces, and then launching your process. So runC is more advanced than Docker in terms of leveraging the feature that exists in the Linux kernel. For example, it has user namespaces already today, and it has CREU. It leverages CREU, which is snapshot and restore for container processes. And there's been a fantastic demo at DockerCon where two of my colleagues launched a Quake client in a container, and then they launched a Quake server using runC on a server in Amsterdam. And they were playing Quake on the client, and then at one point they snapshotted the container that was running on the server in Amsterdam, moved it to Tokyo, and restored it in Tokyo. On the client, you couldn't see any difference. Basically, the client switched from one to the other, and it was in the same state. It kept all the state and all that. So the kind of stuff that you had in VMs, VMware has a similar feature, Hyper-V has had similar features for quite a while. That kind of features is coming, like exists in the Linux kernel, starts to be exposed in runC, so you can use that today. And then it's going to be exposed in Docker at some point, but we need to find the right UI to expose that to users. So we spun out runC as a separate project. It has its own GitHub repository. And yeah, that's a T-shirt I want to print for Solomon. It's like he told me if Linux can do it, Runc should do it. Should be able to do it as well. And the last big announcement we made is, and that's tied to Runc as well. A lot of people came to us and said, "Hey, you're the de facto standard for containers." The people at CoreOS had created another container called Rocket, and they had started creating a spec, and there was some pretty good stuff in the spec. Basically, we all went together and we created the Open Container Project. And when I say all together, it means everybody, like Amazon, Google, VMware, Microsoft, Red Hat, CoreOS, who had created Rocket, participated in that. Basically, we all sang Kumbaya. Alex Povey, who's a CoreOS CEO, went to shake hands with Solomon at the end of his keynote. And basically, we decided to say, we have this format for containers for AppC. We have a certain format. Docker v1, we have one format, and Docker v2, we have one format. Let's go one level down and specify what the file system should look like and the configuration for a lower level tool than Docker, and here I'm talking about Runc, should look like. And that's what we're agreeing on, and so we gave Runc as well as the spec to the Linux Foundation. And it actually made lots of progress in the past 3 weeks. And it's all on GitHub, opencontainers.org. And if you go on github/opencontainers, you can see the work on the spec and on Runc, and you can run and compile it today. We're working to get a first draft of the spec by the end of the month. So that's it for the slides. Let's show you some demos. So first, I wanted to show you a compose file. Or let me show you an application that yeah. So I'm a Java guy. So, oh yeah. Yeah, so I'm a Java guy. So the first app I did, and I used to manage the Spring developer relations team. So my friend Josh Long and Phil Webb built this fantastic app. It's a Spring Boot application using a JavaScript frontend, pretty fancy stuff, and using a MongoDB database with MongoFS for processing images. And so I just took their stuff and put it in a container. So I inherit an image from another guy. Actually, I should move that to the Java official one. And then that has Java 8 and Maven installed. I expose port 8080, and because I'm very lazy, I'm just doing my build in the container itself. So here you can see I just clone the source from his GitHub repo, and then I do a Maven package in there that generates the springdoggy.jar, and then I just, my entry point is I run the server, and I'm supposed to pass to it an environment variable in 12-factor app fashion, and that has a MongoDB URI. So the next step of that is when I want to run that, when I want to run that, I need a compose file because I need Mongo. So that's what I built here. So in that compose file, you see I take my image that I had over there. I just map to a different port because usually 8080 is taken on my machine. I do a link to a Mongo container, and here the Mongo container is just the Mongo image. I'm just running the Mongo database in a container. And then the Mongo DB URI environment variable, here it's Mongo, it should be, it's MongoDB/Mongo. So that's a host name that's coming from the name of this link here. So that's kind of the old stuff, the old way of doing stuff. I could get rid of that part once we have networks. Once you start using Docker native networking, multi-host, you won't need any of that stuff. You just need to put them on the same network and assign services to them. Okay, so I'm targeting a local Docker engine, and what Docker Compose is doing is that it's building these two containers, running them on the host and giving me an aggregated log of both of the containers. So you saw at the beginning what was blue is Mongo, and then my app is starting, and it should be on port 8080 on that guy, and that's, where have I put it? Oh, that's it. So it's called Spring Doggy. Maybe I put it on a different host. Let me just double check what my IP should be in there. I think I'm on dev, so it's 102 or 100. So let's try 102. Now, it's 100.
It was 80, 90.
I think I mapped it to 8090. Yeah, so I mapped 8090 onto that. I don't remember which. Let me see. I just restart it real quickly just to check what. Sorry?
Should be hitting 88.
So 8080 is the port where it's exposed inside of the container. And what I do in the compose file, I'll tell it, hey, expose the port 8090 from the host to that port 8080. So let me just kill that guy and then do an how pipe. Just to see what my
Correct.
Oh. That's better. So it should be on 100. All right, then let's try again. All right. Maybe give it some time to get started. Yeah, it takes a while to start. So while it's starting, I'm going to show you another example, which is in another tab here. And this guy is yeah. So this one is it's a .NET application. So it's a .NET application using ASP.NET 5 with a Docker file that Microsoft built so you can see the Docker file. It's Microsoft ASP.NET, and it's a Docker file for a Linux container running the latest version of .NET with Mono and the .NET compiler on Linux. So here, the only thing I need is to copy my app, and I have a C# file here. So I have a bunch of dependencies to ASP.NET packages. Then I have a simple application here, and so I created the container already. That's the one that was taking 8080. Maybe the port was on. So we'll use 8070 maybe. Maybe it was running already. And that's my ASP.NET app. Yeah, actually it was running already. So that's an ASP.NET app running in a Linux container in a VM on a Mac. The thing, so you're laughing and all that. The first time I saw that, I thought that's ludicrous. Why would people do that and all that? There's some value in there because in lots of shops are using both Java and .NET. Some are using Node and .NET. More and more developers are moving to Macs for development. And Microsoft doesn't want them to not use Microsoft stuff because they're on Macs. So right now, if you're on a Mac, you can, like they even have released Visual Studio Code, which is an editor that works on the Mac. That's not the full Visual Studio, but that's a pretty nice editor. And so there's the answer to developers who want to develop on a Mac for Windows application. There's another angle, which is if today you want to plan for apps that you want to containerize, and make run later on Windows containers when they are available, you can start developing them in containers today with that. At the end of the day, it will be a change, just a change of the from from the image. Actually, maybe the image will have the same name. It will just be a matter of taking the same Docker file and building it on a Windows engine. So that's the second example I wanted to show you. The third one is slightly more involved. It's so I have a Swarm. I have a Swarm cluster installed here. Let me show you what it looks like. Oh, actually, does did my guy end up working or not? Oh yeah, it's working. Whew. No, it's a pretty nice app. It's you're just you take some images. Like for example, I'm going to take a screenshot from the desktop, and no, sorry. And you can drag and drop your images in there, and it's going to put a bunch of like stupid doggy style comments with some really bad Java jokes in there that Josh really loves. On top of your picture, it has it's using WebSocket as well. So when you're So there's a console in there, and if I do some drag and drop, it's showing that in the console in real time. So you can see all the stuff that people are pushing like that. So it's really a nice application. And then it's using Mongo and MongoDB and MongoFS in the backend to store all your images. Okay, so let me go back to that Swarm cluster. So I have a Swarm cluster that's based on 2 machines here. Let me show you. Oops. So let me show you my machines here. So I have a Swarm master here that's on VirtualBox that's running locally on my machine, and Swarm node 00. So when I connect to these guys, if I do a Docker info, so you see here, I have Swarm master. It has 3 containers, and I have Swarm nodes. So I have a Swarm with 2 nodes in there. Imagine that you could have like 100 machines in there, and that could be in a cloud and not on my local machine. But that just gives you an idea. Now, what I did is actually that's a demo I built for Solomon for the keynote. I built a small node application. It's just a 100-line node backend plus some visualization that I can show you here. So that's what it is. So what this application is doing, it's a node application. It's listening to Swarm events. And I'm cheating. I'm just polling. Ideally, I should listen to Swarm event. In reality, every second I'm polling. I'm polling the API of Swarm to say, hey, what kind of Docker engines do you have running? How many servers do you have? And in each server, what kind of containers do you have? And then I do a quick visualization. I just change the icon for when it's a database. When it's Redis, I put a database icon. The rest, I just put an icon in there. And it's refreshing dynamically. The other thing I wanted to show you is I launched Interlock, the system with a plugin with HA proxy that I told you about. So I launched Interlock onto another machine in a container. Oops. And this is the HA proxy config that's generated. Now I'm going to launch a terminal. And actually what I'm going to do is I'm going to go in a terminal and launch like 10 new containers with the host test.local. And in my etc host, I have done a mapping of test.local to the IP address of that HA proxy in there. And then I'll show you what it looks like in the dynamic visualization in the Swarm console, as well as in the HA proxy config. So I'm going back in there. I hope I'm in the right spot. I have too many examples. Oh yeah, this guy. So this guy is a simple, it's a simple, so this is just a loop, and in the loop I'm going to do a Docker run on a random port with a hostname test.local of a demo container. So let's do that. And while he's doing that, let's take a look at here. HA proxy, you see, ooh, I have lots of new hosts in there. And if I go there, I should see, oh, I have all these hosts that are appearing. And you see they become green one by one, which means HA proxy has generated a new configuration. Now it's trying to talk to them. And then when they're all green, that means, oh, okay, all of them are valid. And if I start removing them, they'll turn red and then be removed by HA proxy. And then if I go to test local here, it's hitting HA proxy all the time and load balancing me across all these different hosts, all these different containers. So what that means is that you can schedule your workloads in a clusters of hundreds of machines. I really like that quote by Adrian Cockcroft from Netflix. He said, we need to stop treating machines like pets, but like cattle instead. So here it's really the model of cattle containers where you don't know where they are, you just specify to Swarm the kind of constraints that you want for them. Oh, this guy needs 2 gigs of RAM and run on SSD, and just do it for me, I don't want to know. And then your ops are going to set some policies for Swarm, whether it should be spread or whether it should be a bin pack, depending on how many servers I have, and I could have different Swarm clusters with different characteristics. And then you have something that like Interlock, who listens to Swarm events and dynamically does the load balancing for you and configuration of eventually other stuff. So that's kind of in a nutshell where Docker is at today. One of the things we announced, Evan, the guy who built Interlock, he announced at DockerCon that we're working on a new project that integrates Swarm, Interlock, Docker machine, as well as some new UI for running all your containers. Right now we do the build with the Docker client. We do the ship with Docker Trusted Registry and Docker Hub, but we're not that, like on the run part, we have some tools that are kind of disassembled. We're going to assemble them into a product. I don't know what shape it will take exactly. If you're interested, just watch the DockerCon keynote for the second day, where he did that demo of the stuff that he has today. But basically, we're and the last thing I wanted to show you is Kate Malek. So that's Kate Malek. No need to go on the command line. So here I can create a new Nginx container, and it's downloading the image, launching the container, show me the logs. I can go look. I can go take a closer look to that. I can access the volume where my website files are stored, and I can start modifying my index.html. So that's more for like designers or people who don't want to mess with the command line. You can set all your settings for environment variables and things like that. And one of my favorite features here is they have this exec button where if I click on that, it's going to open for me a terminal within the container. So it's going to do a Docker attach. And if I do a ps-ef in there, you can see I'm inside of the container and there's only one process running, which is Nginx, and the start command for Nginx. So that's called Kate Malek. It's super well integrated with a Docker Hub. So here I'm logged in, and as I'm logged in, he showed me Spring Doggy, so I could actually relaunch it from there. I'll just spare you that. But yeah, so you can have your own containers in there. So that's a really neat tool to look at. And in a recent version that I installed, it even has an easier way of launching a Docker client and setting up all your environment variables for you. So that's all for the demos. Now, if you have any questions, I'll be there. Or do you want to do a Q&A there, or can we go for drinks? Or?
No, if people have questions right now for you.
Yeah, just
that
go
would be
for
great.
it.
Yeah.
Yeah. Yes?
Slides, are they going to be available?
Yeah, definitely. So slideshare.net/Chanezon. You can find a bunch of my existing slides. I'll publish them actually right now, after the Q&A is finished. Yes?
So in the demo that you've shown with CERN, there's still only one HA proxy instance running. Is there
Yeah,
a way
yeah.
to
Yeah.
HA proxy?
Yeah, so no, that's a very good question. The swarm demo that I showed, I launched Interlock only on one process, on one Docker engine. Actually, can you, Aaron, do you know? Yeah, I'm pretty sure you can launch several of these.
Yeah, you can.
But then you need to load balance between them, I guess.
I usually put one on every machine.
Yeah.
But I was thinking, like, say for instance, if you have like a round robin DNS set up to hit multiple HA proxies,
Yeah.
each of them would still, know about the whole.
Oh yeah. So you can, yeah. Because okay.
That's
So
what I do.
okay. So I get the question.
You have like one trigger point of that specific HA proxy container running.
No, because HA proxy config for each of the Interlock instances that you're going to launch, they have the same config because they are talking to the same swarm daemon. So each of them we have the config for all of the containers.
Oh, okay.
So you put a DNS round robin in front of that, and then you're solid. The only thing that was missing in there was the swarm daemon itself was a single point of failure. With the new version, it's not the case anymore.
So there were multiple instances already of HA proxies.
No. In the example I showed you, I did only one, but you can have one per host.
Okay.
That's what Aaron is recommending.
Yeah, that's you can. We're going to be running that in production soon, so we can you can do turtles of HA proxies all like that.
Yeah. Yeah, I actually one of the things I wanted to do was to see if you could do also swarms of swarms. Because you could, like, it could be a very recursive design. I'm not sure if it's doable or not.
So the nice thing about the swarm is it's many to many. So you can have multiple Docker nodes talk to multiple swarms.
But I haven't tried it.
I think it would work.
Yeah, any other? Other question? Sure. I'm sure there's tons of stuff you should try with this. I guess I just hammered you with lots of examples and demos and all that. I'll publish the slides on SlideShare. I highly recommend you to watch at least the two keynote or the three keynotes of DockerCon because there's tons of it. There's tons of more details from what I showed you in there, and the demo of Michael and Arnaud. I think it's in the second keynote. The Quake demo is really worth watching because that's
Closing session or whatever.
that one is really science fiction. But it kind of showed the way of where Docker is going. Yes?
I have a question. Can we allow one Docker container outside of the cloud? Maybe if we have an EC2 instance, can allow service there?
So can a Docker container run on EC2 or?
Yeah, on an EC2 outside of the cloud.
Outside of your, oh yeah. A container is just a process that is launched by another process, which is the Docker engine. So on EC2, there are several options. Either you use Docker machine with the EC2 driver to just, and that takes like 3 minutes to provision your VM over there, and then you target it and you launch a container over there. Or they have also an orchestration engine called EC2 Container Service, where they do all that stuff for you. So you just target it and you just schedule a container to it. Yeah, so it works on EC2, it works on Azure, it works on Google. Google has their own service as well called Google Container Service. Or you can provision VMs with a Docker machine.
I was also wondering if the container itself handles the load from the machine, or
Handles
is
the
it the request from the machine? So let's say I want to have an application on port 80. So would the container handle this port 80? So would my Apache or Nginx be inside the container, or would it be outside? And then I have the direct container from Nginx or Apache.
Okay, okay. So your container is a process, but it has its own network namespace, so it's isolated from others. And then in the Docker file, you specify the ports you want to expose. So that container exposes some ports. And then when you run the container, you can specify a port mapping, where you can say this port on the host is mapping to this port in the container. So for example, you could have port 80 on the main port 80 on the host where you're running. That maps to port 8080 inside of the container. Does that answer?
Yeah.
Yeah. And then with Docker networking, which you can run with experimental. With Docker networking, you'll be able to say, hey, there's a little bit of config you need to. If you want that to work in multi-host and create overlay network, you need to specify a console URL. It's relying on a key value store, and it's pluggable, and you can use, I think, console or etcd. And you need to specify the URL of the console service that each of the Docker engines are going to use to let know of each other what networks exist in that multi-host Docker installation. So once you've done all that config, you can do a Docker network create, and then you can create services, and you can attach containers to services. Once you've done that, each of them have a unique host name into that network. They can talk together on that network, and you can refer to them by name instead of doing linking like we are doing in composing. So that's a big progress.
Tell them about training.docker.com.
About what?
Training.docker.com.
Oh yeah, yeah. If you want to learn more, actually I skipped some of the slides at the end. But if you want to learn more about Docker, so we have training.docker.com where you can learn about like all the training we organize. There's also docs.docker.com is really good. On the blog, John Willis is publishing tutorials regularly. So check the blog. Yeah, and then we're hiring. If you come in San Francisco, we're only 160 people on a total. So, and there's a lot. Like if you remember the mission statement, like building tools of mass innovation, we still have a lot of work ahead of us.
And we're really tired.
Oh yeah, All right. Hey, thanks very much.